Back grade 10s to another video. Okay, so we are going to be doing some exponents today. Okay, some basic exponents, some stuff that you've learned in grade 9, just some revision on that. Okay, and whoopee, okay, because we love maths. Alright, so let's just jump straight into it. Okay, so firstly, some terminology, excuse me, that I would like to teach you guys first. Okay, number one. Alright, so what does this mean? What is a to the power of n? Can you see that a is bigger than this n over here? Okay, so this to the power of n, what does it mean if something's to the power of something, or something has an exponent, or something has an indice? Okay, so there's different terminologies. Okay, it basically just means that this a is multiplying by itself however many times. Okay, so to the power of n, I don't know what that number is, so it's basically a is multiplying with a, okay, until I get to n, okay, and I don't know what n is, so it could be infinity, it could be 5, it could be 2, okay. So let's take a more easier example, or let's take a more a better example. Okay, so let's say 2 to the power of 2. Okay, that basically just means that 2 is multiplying with itself twice, okay, which is 4. Okay, so if we had 2 to the power of 5, okay, that just means that 2 is multiplying by itself 5 times. Okay, and we get 32. Okay, so a to the power of n just means that a is multiplying with itself n amount of times. Okay, I don't know what n is. Okay, it's a number that's a mystery. Alright, so that's what that means. Okay, I hope that makes sense. Alright, number 2, okay, a to the power of 0. Okay, so a can be any number, okay, except for 0. Okay, because 0 to the power of 0 is undefined. Okay, undefined. Okay, alright, so enough about that. Okay, let's just get into, so if a is any other number other than 0, okay, anything raised to the power of 0 other than 0 is always 1. Okay, so a to the power of 0 is always equal to 1. Okay, so that means that 2 to the power of 0 is 1. That means 100 to the power of 0 is 1. That means a bracket to the power of 0 is 1. Okay, that means anything raised to the power of 0 is 1. Okay, except for 0. Alright, so please remember that. Right, that's simple enough. Okay, let's go to number 3. Right, a to the power of negative n. Okay, so now last year you dealt with a few negatives in your exponents. Okay, but now what does that mean? Okay, that just means that we've got 1 over a to the positive n. Okay, so all I did was I just took the a underneath the fraction. Okay, and that's it. Okay, so let's have another example here. So if I had x to the power of negative 1, okay, what would that be? Okay, if I take this to the denominator, okay, my positive exponent now is positive 1, okay, and I've got a numerator of 1. Okay, so what would happen if I had this to the negative 1? Okay, 2 positive 1 exponent. Okay, remember anything, everything is raised to the power of 1 if there's nothing there. Okay, if there's nothing there, it's always raised to the power of 1. Alright, positive 1 exponent there for 2. Okay, and a is now negative 1. Okay, now it's a little bit different. Okay, the 2 is going to stay at the top. Okay, and then we're going to take the a to the bottom and positive 1 exponent. Okay, so let's try another one here. Okay, if I had 3 x to the power of negative 2, what would that be? Okay, 3, what's the exponent here? Positive 1. Alright, so 3, is he going to go underneath, or is he going to stay at the top? He's going to stay at the top. Okay, so 3 is positive still. Alright, this isn't positive, I want to make it positive, so I'm going to take it underneath in the denominator of the fraction. Okay, and I've got x, and now this negative 2 becomes a positive 2. Right, I hope that makes sense. Okay, and then now let's get into some laws. Okay, some laws from grade 9, okay, of our exponents. Okay, so law 1. Okay, law 1. Let's look at this. Alright, so we've got a to the power of n multiplied by a to the power of m. Okay, so when I have same bases, okay, so this is called a base. Okay, this is your exponent. Okay, so when I've got same bases, a and a, okay, I'm going to add my exponents. Okay, so I keep the letter a, whatever the base is, so in this case it's a, okay, base of a, and I'm going to add the exponents. So n plus m, because it's the same basis. Okay, so if I had this, so say 2 multiplied by 2 to the power of 2. Alright, let's see what that is. Okay, do I have same bases? Yes, I've got a 2 and a 2. Okay, so am I going to multiply these bases together? No. Okay, so a, I'm going to keep the base the same. Okay, so keep the base the same. Okay, same base, keep the base the same. Alright, and what do I do when I've got same bases multiplying with each other? I add the exponents. Okay, what is the exponent here for 2? It's just 1. Okay, so 1 plus 2 gives me 3. Okay, and what is 2 to the power of 3? 8. Good. Okay, let's check ourselves. What is 2 to the power of 1? It's just 2. Multiplied by 2 to the power of 2. What is 2 to the power of 2 in normal numbers? It's 4. Okay, so 4 multiplied by 2 is 8. Okay, so I am right. Okay. Right, let's try another example. Let's try this one. 2 multiplied by 3 to the 2. Right, do I have same bases here? No, I don't have same bases here. Okay, so I can't multiply the bases. I can't add my exponents. Okay, so a lot of kids, what they do is they say, okay, this is 2 times 3, which is 6 to the power of 2, or they add these exponents, this 1 and the 2, and they say, okay, it's 6 to the power of 3. Okay, that is wrong. Please don't ever do that. Ever in your life. Don't ever do that. Okay, alright, so we've got 2, which is just 2, multiplied by, what is 3 squared? 9. Okay, and what is 2 times 9? 18. Okay, then we just do that normally. Okay, only add the exponents when the bases are exactly the same. Alright, I think that makes sense. Go to law 2 here. Okay, so law 2 is basically just the opposite of law 1. Okay, so look here, we've got a to the power of n, a to the power of n, a to the power of m, a to the power of m. Alright, but now, what's the difference? I've got a divide here, and here's a multiply. Alright, so what did we do here when we multiplied the same bases? We added the exponents. What do you think you're going to do when you divide same bases? If multiply is the opposite of divide, okay, you're going to do the opposite. Okay, and what's the opposite of addition? Subtraction. Okay, so we're going to subtract our exponents. Okay, alright, so get some examples here. Let's say 2 to the power of 3 divided by 2 to the power of 2. Alright, what is that? Okay, so I keep the same base. Okay, I've got same bases here. Okay, whatever that base is, I'm going to keep it. Okay, same base. 2, 2, 2. Alright, don't change this base. Don't say 2 times 2. Okay, that's 4. No, that's wrong. Okay, keep the same base. Right, now look at the exponents. And what must I do with the exponents when I'm dividing same bases? I subtract. Okay, so what is 3 minus 2? It's 1. Awesome. So that's the answer of just 2. Okay, so let's check ourselves. Okay, what is 2 to the power of 3? 8. Divided by 2 to the power of 2? That's 4. And what is 8 divided by 4? 2. Okay, so I am right. Alright, so you can always check yourself like that. Okay, let's check another example. Let's say 3 squared divided by 2 to the power of 3. Alright, what is that? Okay, do I have same bases? No, there's no same bases here. Okay, there's no same bases here. Okay, I can't multiply the bases either. Okay, because I don't have the same exponents. Alright, so I know what 3 squared is, which is just 9. Okay, so it's 3 squared divided by 2 to the power of 3. So it's 3 squared, which is 9, divided by 2 to the power of 3, which is 8. Okay, so only subtract your exponents when your bases are the same, please, guys. Okay, alright, moving on. Law 3. Okay, so over here, so now we see that we've got an exponent and we've got brackets now. Okay, so what we're going to do here, okay, what this law says is that you are going to multiply, okay, this exponent with the exponents of everything that's inside. Okay, so what's the exponent of A? 1. What's the exponent of B? Also 1. Okay, when there's nothing there, it's always 1. Okay, and what is 1 times n? N. And what is 1 times n? N. Okay, so we've got A to the power of n, B to the power of n. Okay, so all I did was I just multiplied. Okay, I multiplied n over there. Okay, I'm only multiplying. What am I working with? I'm working with exponents. So I'm only multiplying exponents. I'm not multiplying this a with the n and getting a n like that times bn. Okay, no, I'm not doing that. That's wrong. Okay, I'm multiplying the exponents. Okay, so let's see some example here. Let's try this one. Okay, let's try something like that. Alright, what does that equal? Okay, so remember, what am I doing? I'm multiplying exponents. Okay, so I see that there's a 2 outside the bracket. Okay, that means that I've got powers being multiplied here. Okay, so I'm going to say 2 times 2, that gives me 4. No, okay, you should be shaking your head on the other side of this video. Okay, I'm not multiplying numbers with this exponent. Okay, what is the exponent of 2? 1. Okay, 2 to the 1, 2 to the power of 1, a to the power of 2, and b to the power of 1. Okay, so now I'm going to multiply the exponents. Okay, so we've got 2 to the power of 1 times 2, which is 2. Okay, and then we've got a to the power of 2 times 2, which is 4, and b to the power of 1 times 2, which is 2. Fantastic. Alright, hoping that makes sense. So please, guys, always remember you are multiplying the exponents, not the numbers. Okay, in this case, it does happen to be 4, but that doesn't always happen like that. Okay, it doesn't always happen. Okay, so we've got 4, which is 2 squared, and a to the power of 4, b to the power of 2. Okay, right, hoping that makes sense. Nice and easy. Okay, and the last law for today. Okay, we're going to say, can you see that this is basically exactly the same as this one here? Here we're multiplying a and b. Here we're dividing a and b. Okay, so it's nothing different. We've got an n outside here. Okay, and we're going to multiply with the exponents again. Okay, so this exponent outside is going to multiply with the exponents again. So we've got a to the power of 1 multiplied by n, which is a to the power of n. And we've got b to the power of 1 times n, which is b to the power of n. Okay, so let's try some examples. So it's 2a over b squared. Okay, all to the power of 2. Okay, want you to try that? Alright, so I can say, okay, I'm going to say 2 times 2. No, okay, you should be shaking your head. Okay, it's not exponents multiplied by numbers. Okay, what's the exponent here? 1. Okay, what's the exponent of a? 1. Okay, so we've got 2. Okay, and 2 times 1, which is 2. And we've got 1 times 2, which is 2. All over b, we've got 2 times 2, which is b to the 4. Alright, let's simplify a little bit. We've got 4a squared over b to the power of 4. Okay. Alright, let's jump into some examples here. Alright, let's see here. Okay, pause the video, see if you can do it by yourself. Okay, I assume you've done it. Alright, so can you see we've got same bases? Okay, same bases of 2. Alright, so I'm going to keep the 2. And what do I do when I multiply same bases together? I add my exponents. Okay, so I've got 2 plus 2. Okay, which gives me 2 to the power of 4, which is 16. Very good. Alright, easy example. Right, let's look at this one. Okay, so when we divide, okay, and we're dealing with exponents, I want you guys to always set it out this way. Okay, it's going to help you in the future. Trust me. Okay, it's a good habit to get into. Alright, so when I divide same bases, okay, this just means divide. Okay, this line over here just means divide. Okay, so when I divide same bases, what do? I subtract my exponents. Okay, so I keep whatever the base was, so base of A, okay, and it's always top minus bottom. Top minus bottom. Okay, so we've got 2 minus, what is the exponent here? 1. 2 minus 1. Alright, let's leave that. Multiply. This dot just means multiply. Okay, what is this b to the power of? 1. What is this b to the power of? 1. Okay, so always top minus bottom. So we've got b to the power of 1 minus 1. Okay, now let's look at the c. The c is to the power of 1. Okay, so multiplied with a little dot there. C, and it's always top minus bottom. Okay, so top, which is 1, minus the bottom. Okay, now let's simplify that. So we've got a to the power of 2 minus 1, which is 1. You don't have to put that there. Alright, I'm just showing you. And then we've got b to the power of 1 minus 1, which is b to the power of 0. Okay, b to the power of 0. Fix that, b to the power of 0. Alright, and then we've got c to the power of 1 minus 2, which is negative 1. Fantastic. Alright, now let's simplify this a little bit. What is anything to the power of 0? 1. Okay, so we've got a multiplied by c to the power of negative 1. Okay, so the 1 doesn't matter about the 1 there. Okay, so 1 times a is just a. Okay, right, now if I told you, take this answer, okay, and I want you to put it in positive exponents. Okay, I want your answer in positive exponents. Okay, so here we've got a negative exponent. So how will I make it positive exponents? Okay, so let's go back to our terminology. Okay, so our third one over here. Okay, so we had a to the power of negative n. What did we do? We put it in the denominator and we made it positive, and we had a 1 at the top. Okay, here we had a 2a to the negative 1. How did we make this negative 1 positive? We took the a to the bottom, the 2 stayed because the 1 is positive. Okay, so 2 to the 1 stays at the top, and we take the a to the bottom and the 1 becomes positive. Okay, so now let's look at this example that we're busy doing. Okay, so a to the power of 1, positive 1. Okay, so a is going to stay at the top because it's positive 1. Over, now we're going to take the c to the bottom of the fraction. C to the power of positive 1 now. Okay, so that negative 1 becomes positive. Okay, so sometimes in your questions, in your exams, they will say, please leave your answers in positive exponents, with positive exponents. Alright, and then that's how you do it. Okay, so you'll get a negative answer, but that doesn't matter. You just take it underneath and you make it a positive exponent. Okay, please always set it out this way. Okay, start getting into good habits now. Okay, it's going to help you later on in grade 10. Okay, right, let's look at this one. Alright, pause the video, see if you can do it by yourself quickly. Yeah, I assume you've paused the video. Okay, let's do it together. Alright, so we've got 2 to the power of 1, a to the power of 1. Okay, I see that there's an exponent outside of a bracket. So what am I going to do with this exponent? I'm going to multiply it with every exponent inside. Okay, so I'm left with 2 to the power of 2, a to the power of 2, and b to the power of 4. Okay, so I just multiplied this 2 with the 1, 2 with the 1, 2 with the 2. I've got 2, 2, and 4. Okay, and what is 2 to the power of 2? 4, a squared, b to the 4. Alright, moving on, last example for today. Alright, I want you to pause that. Okay, watch the video. Alright, and let's see what's happening here. Alright, so I assume you've done it. Okay, let's look at this. Right, so I see I've got 2 to the power of positive 1, b to the power of positive 1, and this a over here to the power of 1. Alright, so I see I've got exponents on every letter. Awesome. Alright, so now I see that there's an exponent outside of my brackets. What must I do with this exponent? I need to multiply it with every other exponent inside. Okay, so let's see. Alright, so I've got 2 to the power of 1. Okay, so 1 times 2 is 2 to the power of 2. Okay, then I've got a to the power of 4, that's 2 times 2. B to the power of 2, that's 1 times 2. All over 2 to the power of negative 2. Okay, negative 1 times 2 is negative 2. A to the power of 2, that's 1 times 2. And we've got b to the power of 4, 2 times 2. Alright, now I see I've got same bases everywhere. Okay, what do I do when I've got same bases and I'm busy dividing? Okay, I minus my exponents. Okay, so let's see here. Okay, so I've got 2. Okay, and I've got top minus the bottom. So I've got top minus, now careful here, minus 2. Okay, so 2 minus negative 2. Okay, 2 minus negative 2. Right, then I've got base of a, and I've got top minus bottom, which is 4 minus 2. And then I've got b, right, and I've got 2 minus 4. What is 2 minus 4? 2 minus 4. Okay, now let's simplify here. Let's take this up over here because I'm running out of space. Right, and what is 2 minus minus 2? Good, that's 2 plus 2, which is 2 to the 4. Right, then I've got a to the power of 4 minus 2, which is 2. And I've got b to the power of 2 minus 4, which is negative 2. Alright, now I need to simplify here. What is 2 to the power of 4? 16. A squared b to the negative 2. Now what I want you to do is I want you to write this answer with positive exponents, please. Okay, pause the video quickly. Positive exponents. Alright, so I assume you've done it. Okay, let's see. Okay, so 16. Okay, 16 is raised to the power of 1. Okay, so it's a positive exponent. A to the power of 2, it's a positive exponent. B to the power of negative 2. Okay, that's a negative exponent. So what am I going to do with that? I'm going to take him down to the bottom. Okay, so 16 stays at the top because it's to the power of positive 1. Okay, and a positive 2 stays at the top, and I take the b down underneath. And it becomes positive 2. Right, so those answers are both right. Just check what your question asks you. Okay, sometimes they won't say positive exponents, but most of the times they will. Okay, so you'll get an answer like this, and then you say, okay, I want positive exponents, so you just take it underneath, and there's a positive. Alright, I hope that helps. That's an introduction to exponents for grade 10. Okay, I hope this video helps you with your exams and your tests. Okay, good luck grade 10s.